Okay, let's look at exercise 61 from section 4.2. This is problem 10 of the section 4.2 homework. And we want to graph f of x equal common log of x. Remember, if we see log and there's no base written, the base is 10. So we first want to graph that in its asymptote. Then we want to use transformations of this graph to graph h of x equal the common log of x minus 4. All right, so we have to understand that the way this is written, since there is not a parenthesis, the common log only applies to the x, and then we're subtracting 4 from that. So let's start by graphing the common log f of x, which equals the common log of x. So we click on our graph, we pick our logarithmic graphing tool, and we know that when x is 1, the common log or any log of 1 is always 0. So we know that's a point on our graph. Now the problem automatically gave us a problem whose base was 10. So when the tool pops up, it actually gives you the base for the problem. And because the original y was f of x, which equals the common log of x. The new y, when we look at h of x, subtracts 4 from the old y. So whenever you're changing your y by subtracting 4 units from every y, that is a vertical shift downward. So that's a vertical shift, and our shift is downward 4 units. So we put a negative 4 to indicate a vertical shift downward. And we see that it moved the graph downward. Now we are also being asked to graph the asymptote, which is, we pick the line tool and we're going to dash, and so we plot a point on the 2 points on the y-axis. The y-axis is our asymptote for this type of logarithmic equation. And also, we click in the graph once we have the line determined, and once these are blue, we now have the graph along with the asymptote. We're going to check our answer. Next question, what is the vertical asymptote? It is the y-axis whose equation is x equal to 0. So any point on this vertical line, which happens to be the y-axis, has to have an x coordinate of 0. Y can be any value, but x must be 0. Now let's give the domain of this function. So we notice that our domain is any positive x. As long as x is positive, it will be an x that corresponds to an x coordinate of one of these points on this graph. And now we're being asked for the range. Now this graph does extend indefinitely. So it rises slowly, but it does rise. I just have to keep extending it. So eventually, I'm going to get every possible y value, whether positive or negative. And actually, when x is, now remember, it's increasing very, very, very slowly. I don't get the y value of 0 until my x is 10,000. The common log of 10,000 is 4. So then I'll have 4 minus 4 as my y value when x is 10,000. So I won't even reach the x-axis until my x is 10,000, but I will reach it if I just extend far enough. So this graph is increasing, but it's increasing very, very slowly. So I get every possible y value. I get every negative y, and I get every positive y. It's a little hard to see that because the graph is increasing so slowly. And that's how I would work this problem.